G'day guys, how you going? This is our first lesson to do with projectile motion. I just want to go through a PowerPoint I actually used with my Year 12, so you might see this again, but it really goes through everything you need to know with projectile motion. Now, in Year 12 the application is sport. We'll be looking at other applications in Year 11. So just some examples of applications where you'll see projectile motion, right? So things like sport, doing jumps, obviously soccer, and obviously satellites is an example of, or space travel is certainly an example of where we use projectiles. Alright, so the thing is, with projectile motion, you actually know a lot about it, even though you don't know the formulas and the mathematics behind it, but you certainly have that understanding about when you throw something to someone, you know that if you want it to land in their hands, you have to throw it above the position where it needs to land, because you know it's going to fall due to gravity. Alright, so these are the things that we will consider when we're looking at projectile motion: the effect of air resistance. We'll be looking at the launch angle and what that best launch angle might be to get maximum range, and how long does it take the launch angle to affect things like the time of flight and the range. So those are the three things that we will be considering when we're looking at projectile motion. The different types of motion that we'll need to consider will be the ground to ground, above ground to ground, horizontally above the ground to the ground to above ground, and above ground to above ground. Now, the thing that you look there, you might go, oh, that looks a little bit confusing. Well, it doesn't really matter, because we're going to use the same formula, the same process for all of those situations, so don't be frightened by that. The formulas that we will use are, in fact, these ones here. It's really, these two formulas are just a variation of the same formula, and really what we do is we break the distance formula into horizontal and vertical components. Alright, so, and then this one here is the final velocity one that we use when we're trying to find the time of flight, or the maximum height, or the final velocity of a projectile. Alright, steps to follow. So the first thing that we would normally do is find the initial vertical and horizontal components of velocity. Okay, and that includes just using a bit of trigonometry. Alright, so we say the angle and v, the velocity that it's been launched at, we can break that into the vertical and horizontal components. So v sine theta, v cosine theta. I think that's something you should cope well with. Step 2, we normally have to then try and find the time of flight. So we use that by using the SV formula. All we do is we change the actual height. So if it's going upwards, then SV will be positive. Okay, if it's not changing its actual height, so let's say it's been launched and going back to the same launch height, then we'd make SV equal to 0. And if it was being sort of dropping down, right, from the original height, so it's actually going to land lower than its original height, then what we will do is we'll use a negative SV. Right? So all we do is we then put into that equation. Now it works out pretty simply. You can actually find that using your graphics calculator to find the values of t if we have to. Now we need to find the range of the projectile, so we place that into the formula, which is SH equals VH times by the time of flight. And again, we can just solve that by timesing those two things on the calculator. Alright, step 4, we generally find the velocity of the projectile at any time. Alright, so what you know is we have to find the final vertical velocity to do that. The horizontal velocity of a projectile, once it's been left, actually doesn't change. Right, one of the key things that we will use is the idea that the horizontal acceleration is 0. The only acceleration the projectile experiences once it's left the launch position is in fact gravity. Right, so to do that, we know that our horizontal velocity doesn't change. We can use our vertical velocity, and knowing our initial velocity and how long it's in the air for, and gravity, we can actually work out the final velocity, and then we can use Pythag and trig to find the angle, but also the quantity of the velocity. The final thing that we might want to find is the maximum height of the projectile. Now when we're launching something into the air, when it gets to the topmost point, it's only going to have horizontal velocity. It doesn't have any vertical velocity because it's not going up or down anymore. So therefore we can use that formula in B to work out if we make that equal to 0, we know the initial velocity, we know what acceleration is, that will allow us to find the time. And then once we know the time, we can place that back into this formula here to work out how high it actually is. Alright, so they're all the things that we will need to consider when we're doing that. So I'll go through some examples of projectiles that would be useful, right, in terms of doing that.